This is a video showing a finite state machine, which is, in this case, implemented by a ROM memory chip with data programmed into it. And the way this works is we have the data line output from the ROM chip recycling back around through a flip-flop, a D-type flip-flop. So basically every address that's called up, the data read from that address location becomes the next address. And by doing this, you can program all kinds of interesting and arbitrary sequences. In this particular case, if we look at the memory map that we've got programmed into this ROM, we see that if we start at address 00, the first data in that is 01, so it's going to go to address 01. Then from there, we look up data 02, that tells us to go to address 02, etc., etc. It gets interesting here when we get to the step of address 4. It says to go to address 5, and when it says to go to address 5, it goes to address 0D, which is actually located over here. And what that does is it basically outputs the lower 3 bits as a binary 5, but with an additional bit up here not connected to an LED, suddenly turns to a 1 to make the hexadecimal D. That feeds back around to give that 0D address. And then in the 0D address, it says, okay, here let's go to address number 6 next. We go back to 6, and we continue the sequence to 7. We go to 7, we go all the way back to 0, and we repeat. So what happens when you take a look at the LEDs is that they appear to count 1, 2, 3, 4, 5, 5, and then 6, 7. 0, 1, 2, 3, 4, 5, 5, 6, 7. So that extra bit here that gets recycled as part of the next address, but is not illuminating an LED, helps us to duplicate the output of 5, the 101 here that we saw for 2 clock pulses. So it's just an interesting way of using a memory chip to implement arbitrary sequences, called a finite state machine.